Alright, hi everybody. So this is the video for Tuesday night. And I have changed the homework a little bit. I'm going to do fewer notes and have you do a little bit in the book. So there are two videos, this one and then one other that it doesn't have slides. It's 3 word problem examples. So you'll do this one first and then do the next one. They'll be separate so they're not as big. And then a few problems in the book. Okay? So these notes I think will be relatively quick. So this is about systems of equations, and there are 3 possible outcomes we can have when we graph 2 lines. So one of them is that the lines have exactly one... Ooh, that's not what I meant to do. Okay, exactly 1 point in common. So that would be the case here. Now we don't have to, so let's graph these. The m is 1/3 for this, and the b is -2. So let's graph that one first. We got a b of -2. We go up 1/3. We can also go down 1/3, and we get our first line. Our second line has a slope of -4 and a y-intercept of 3. So I graph the y-intercept. I have a slope of 4, so I'm going to go down 1, 2, 3, 4, and over 1. 1, 2, 3, 4, and over 1. And graph the line. Okay? Remember to put arrows on your lines because they go on forever. And typically we write the name of the equation beside the line so we know which line is which. So this line is y equals -4x plus 3. And the other line is y equals 1/3 x. We try to write it on the line, but sometimes that doesn't work. Okay, so here's an example of 2 lines, a system of equations. The equations, when you graph them, cross. And so there is one solution. And this is called a consistent. C-O-N-S-I-S-T-E-N-T. This is called a consistent system. Okay, so that's one option. They cross. The second option on the next slide, case 2, is that the lines have no points in common. Okay, and if we look at these equations here, we see that this one has a slope of 3 and the y-intercept is 1. And if we look at the other one, we see that it has a slope of 3, and the y-intercept is -3. So we know those are going to be parallel, which means they have no points in common. I'm going to graph the blue one first. So I have a y-intercept of -3. I go up 3 over 1, up 1, 2, 3 over 1, and then I graph the line. Don't forget the arrows. And then before I label it, I'm going to graph the other line because I don't know where it'll be. So my y-intercept is 1, my slope is up 1, 2, 3, and over 1. I go down 1, 2, 3, and over 1. Graph the line. Okay, there's my second line. So the pink line is y equals 3x plus 1, and the blue line is y equals 3x minus 3. Those never cross. So this system is called inconsistent because it does not have a solution. Okay? So anytime something has no solution, it's inconsistent. Okay? No solution. Okay? And then we have 1/3 and final case, which is when we have an infinite number of points. So you might think about how that can happen. If we look carefully at these 2 equations, I'm going to leave the first equation alone. The second equation, I'm going to divide everything by 2 because I want to get it in y equals mx plus b form. And when I do that, I get y equals 3 halves x minus 2. Well, check it out. That's the same as the first equation. So this is a case where the lines, it's only one line. Right? The 2 equations are actually the same. So I'm going to graph that, -2, and then I go up 1, 2, 1, 2, 3, and over 2, up 1, 2, 3, and over 2, and graph it. Sorry, my pen got that line a little thick. Okay, so two equations, same line. So these are, that line's a little bit off, sorry about that. So this system has an infinite number of solutions. Infinite number of solutions. Because if the two lines are on top of each other, then every point on the line is a solution. And so this one is consistent because it has a solution. Now, I didn't talk about this, how we write the solution of this, and so I'm going to write it up here because there's not room on the bottom. So the way we write the solution to this is, first of all, we write in set notation xy, because in this case our solution is an ordered pair, right? It's not just a point. And then what we do is we write the equation itself, because the equation itself tells us where the points are. So because every single point on this line is a solution to both equations, the solution to the set is actually the equation of the line. So I probably should have included this in yesterday's notes, but I didn't, so here it is. So this is the solution to something that has an infinite number of points. Okay? Going on to slide 9, this summarizes all of this for you. Okay? So consistent means there's at least one solution. These lines are going to intersect. Right? And then inconsistent means any system of equations with no solution, so these lines are going to be parallel. Now, this first one, consistent, could also be the same line as was the case in one of our examples. Okay? Now, we have two more words we use to describe systems, which are independent and dependent. And independent means that one equation is not a multiple of each other. So this means the lines intersect or the lines are parallel, because neither one of those cases are the lines multiples of each other. Equations, I'm sorry. But in a dependent system, you might notice if you go back and look at the slide, let's see, this would be slide number 8. Notice that in case 3, right here, the two equations are multiples of one another. This top equation, if you multiply it times 2, you get the bottom equation. So whenever two lines are right on top of each other, they're going to be multiples of each other. So that's what happens in a dependent system. This would be the two lines are the same. Okay? Alright, so going on to the next slide. These are examples. So, since you can tell whether two graphs are going to be parallel, or they're going to intersect or be the same line, just by looking at the equations, we don't need to graph them to figure out whether they're inconsistent or dependent or whatever. So, in this case, here we're supposed to tell, is this system independent or dependent, and consistent or inconsistent? So our question is, do they intersect? Are they parallel? Or are they the same line? Which means the equations will be multiples of each other. So we need to solve these for y. So this will be y equals negative 3x plus 5, right? If I subtract 3x from both sides. This equation will be negative 3y equals negative 2x plus 7. I'm going to divide everything by negative 3. And I get y equals 2/3 x minus 7/3. So those two lines have different slopes. So if they have different slopes, then you guys know that this figure, this 3 dots means therefore. In mathematics and science, we often use that instead of writing therefore. So they have different slopes, therefore they intersect, right? And therefore, because they intersect, they are consistent. That means there's a solution, and they are independent. Okay? You might want to pause and look back through that again. Okay, here's another example. Same thing. We want to know if they're independent or dependent, and consistent or inconsistent. So once again, what we want to know is, are they parallel? Are they intersecting? Or are they the same line? Okay? So, the first equation, there might be a question here about what's the independent and what's the dependent variable. We're going to assume that this is TW because we usually use alphabetical order when we list variables. Okay? So, the first equation is already done for us. It's T equals. And the second equation, we're going to subtract 2w from both sides. Okay, and we get t equals negative 2w plus 6. So you'll notice here, slopes are the same, right? So that means they're either parallel or they're the same line. So the thing we have to ask ourselves is, what about the y-intercept? Because the y-intercept is going to tell us if they're the same, then we know the lines are the same. If the y-intercepts are different, then we know these lines are parallel because they have the same slope. By the way, going back to here, the slopes are equal to negative 2. Okay? So if we look at the y-intercepts, the first line, the b in this equation is 4, and the b in this equation is 6. Okay, they're different. So that means the lines are parallel, which means, therefore, the system is inconsistent because there is no solution, and it's also independent because they're not the same line. The only time they're dependent is when they're the same line. Okay? So here we have our final slide. I'm sorry it got messed up here. I don't know what happened when I imported it. But what I wanted to tell you on this slide is we essentially have 4 ways of solving systems of equations. Informal, graphing, which we've now done, substitution, which we'll do next, and elimination, which we may not do until after winter break. Thanksgiving break. So that's just kind of an overview of our methods. These informal problems were the ones we did. These here were the ones we did with the chicken and so on. Okay, so I'm not going to do any more notes or slides, but I would like you to do a few problems in the book. To practice this stuff. So, page 155, numbers 1 through 8, that's a vocabulary thing. Number 15, number 35, and number 63. If you would like to do an advanced assignment, then do, instead of number 63, do number 65. Okay? So please do those problems. These are vocabulary. This one is solution, deciding whether something's a solution. This is a graph. And this is reading a graph. Okay? Thanks. See you on the block day.